Today we have to discuss about the negative shunt clipper with positive bias by using the pspice software. Here, this is a diagram of the negative biased clipper. Here, the it is a input voltage which is sinusoidal, and it is a zero node, and it is one. This is a one node, and this is node number 2, and here it is node number 3, and here it is node number 0, which is a common to the ground. So if we want to simulate the circuit of negative biased clipper by using the pspice software, we have to know about the number of nodes. So first of all, we have to know about the number of nodes in the circuit. So here the number of nodes are 1, 2, 3, and 0. It is three nodes, basically 4 nodes. Actually 1, 0, 1, 2, 3, and 4. 0, 1, 2, and 3. So we have to simulate this circuit. How to simulate? By using the pspice. Now open the pspice software, and here going to the file and click the new, which is a text file. Actually text file. This is open a new window, and now we have to write some codes to simulate, to perform, basically to perform, or basically to simulate the negative biased clipper. So how to simulate, and what is the codes? What are the codes to simulate the negative bias clipper? So first of all, we know about the source is between from 0 to 1 node, like we write Vs. Basically it is a sinusoidal signal. We have write anything, Vi, V only, V1, Vs, and it is between 0 and 1 and 0 basically, and we have the sinusoidal signal. So sine, this is an average, a starting point 0, and the peak point basically 1. And if we want to 5 volt, if we have the signal that is 5 volt, the amplitude is 5, and 5 kilohertz frequency of that signal. Okay, now from node 1 to 2 there is a resistance basically of 1 kilo ohm. So resistance for R, and it is 1 and 2 and 1 kilo ohm. Okay, now there is a diode between 2 and 3 nodes. So but the diode is reverse bias, so basically is a negative bias clipper diode D. I only write D only. If you want to D1, D2, if there is a number of diodes more in the circuit, then you write D1, D2, D3. So D, the node is 3 to 2. So it is a basically it is a reverse bias diode. So if you want to write for reverse bias diode, the nodes are interchangeable. This 3 to 2, not through 2 to 3. It's not a forward bias diode, so it is a negative bias diode. And so I write its name TM Sion, and we have a DC voltage in the bias voltage, basically VI, only it is V, and it is between 0, 3, because it is negative bias. So it is DC on. And for a diode, here is a command for model a diode. We have used this semiconductor diode basically. So the model is model, the name of the diode, dm, and d is the parameter. We have some parameter like saturation current may be equal to 1 e to the power 10, and the factor is n equals to 1, the change in level factor. Okay. And we know about the transient response, so we click for the transient response. We write for the transient response command. This is trans is 1 u and 1 milli. Okay. Now for print this Bob command in capital letters, and it is the end command. So this is a simulation of the negative biased clip circuit. This is a net list basically. So we want to save this file. First of all, now we go to save it. Save. Now here the save as type, we have the CIR file. Now to click the CIR file, it is CIR file. Name this like clipper. I clipper dot CIR. Okay. Now save this. Now cancel this and open file, which is now the file of type basically CIR. Then go into the CIR, and here there's a file which are based on the CIR. It's coming all the files which are based on the CIR are here. Now clipper, open the file here. Now the file is saved and it is ready to run. Now run this file. Here simulation, goes to the simulation and run the clipper. If your netlist is correct actually, then you show this blank window. Otherwise it shows some error actually. The error here is signified here, but is not here. There is no error here. So our netlist is correct. Okay. Now we have to trace some inputs and outputs waveforms. As we know, so first of all, we add the trace, and we go to the V1. V1 is basically our sinusoidal signal. So we have V1, basically it is a sinusoidal signal. Okay. And now the clipper, what the work of the clipper clips, the negative bias clipper clips the negative waveform, and he only allow the positive waveform as it is, but it clips the negative waveform by some portion. Now how to check it is clipped? Now go to the trace and add the trace and goes to the V2 and okay. Here what we get? Here the negative biased clipper. Here the negative waveform is clipped. This is an input waveform. Here the green waveform is an input waveform and the red waveform is the output waveform. So we see that the red waveform is cut by some portion. This is a negative biased clipper. So we know about the working of the negative biased clipper, and if we want to simulate this by using a pspice software, we know some codes for definitely these codes are, it is very easy actually. We have VS from 1 to 0 node, R from 1 to 2, diode which is a reverse biased. If it is a forward bias, then it will be 3, it is not for 3 to 2, it is 2 to 3, and the device and the biased battery, which is the node 0 to 2, is actually 3 to 2 for a forward biased clipper. So this is our net list for the negative biased clipper, and we see in the object, we see in the output of this experiment, and If you want to recognize, which is not a which is a very thin waveform, now if you want to make it wider, now go to the properties and go to the width and select the width. Okay, now it is visible now. If you want to select the graph, select it, right click, properties, and now width, which is this is basically the output waveform for the negative biased clipper. If you want to trace the positive biased clipper, the only effect change the direction of the diode and the bias battery. If you want, let me show that. And cancel this window. Okay. Okay, now I want to simulate the positive bias clipper. So how to simulate? We interchange position of the diode. So it's the 3 here. I will replace it by 2 and 3, and the bias battery is also replaced by 3 and 0. Now save it again and simulate it. Okay, you see that the positive biased clipper works as he cut out the positive waveform actually. So this is a output waveform basically. Green is output wave. Oh, sorry, green is an input waveform, and it is a sinusoidal. And the red is the output waveform, which is a clipped version of the input waveform. The positive wave is clipped out here. Positive wave is clipped out, and the negative is as it is as an input wave. So it works as a positive bias clipper. It is simple. So thank you very much to see this video, and like and share. Okay, goodbye.